All right, let's just jump right in. Welcome to this explainer, where we're going on a seriously fascinating journey today. We're going to start by zooming way in on the microscopic chemistry of a tiny, simple flame. And then we're zooming all the way out to the macro scale of global energy and the literal atmosphere that surrounds our planet. So if you've ever wondered how the mechanics of a single burning candle somehow connect to the massive solar farms powering our modern world, well, you're in exactly the right place. Here's our roadmap for today. First, the secret of the flame. Second, decoding our atmosphere. Third, exposing the invisible byproduct. Fourth, measuring what we breathe. Fifth, history and the greenhouse effect. And finally, harnessing the sun. Let's do this. But hey, before we look to the future, I want you to think about a mystery. It's something so basic, yet honestly, deeply profound. Why does a fire eventually suffocate in a closed space? It's something we've all probably seen, right? Or at least heard about. But what is actually happening on a chemical level when that flame flickers and dies out? Keep that question right in the back of your mind. Section 1. The secret of the flame. The basic chemistry of combustion. Take a look at the sheer simplicity of this experiment. On the one hand, you've got a lantern with the flame just thriving in the open air. But then look at the bottom sequence. We place a candle on a stand, cover it with a glass jar, and at first it burns totally normally. But the second that jar is sealed tight, the flame quickly weakens, shrinks, and just dies. Why? Because a continuous supply of fresh air is absolutely crucial for a fire to exist. The flame is literally consuming what it needs from the air inside the jar, and when that invisible fuel runs out, the combustion just stops completely. Now, to see how this builds into undeniable scientific proof, we can break down a classic scientific method. Imagine we take 3 separate glass jars and fill them with equal amounts of 3 totally different gases: nitrogen in the first, oxygen in the second, and carbon dioxide in the third. When we place a lit candle into the nitrogen jar, the flame goes out. When we place it into the carbon dioxide jar, the flame goes out. But in that middle jar, the oxygen jar, the candle just keeps burning brightly. This brilliantly illustrates that oxygen is the undisputed, vital catalyst required for a fire to burn. Without it, no way. You simply cannot have a flame. Section 2. Decoding our atmosphere, breaking down the invisible gases around us. Check out the exact composition of our atmosphere mapped out here. A lot of people are actually surprised to learn this, but our air is heavily dominated by nitrogen, making up a massive 78% of the volume. Oxygen, our vital life giver and fire starter, makes up only 21%. And look at that tiny little sliver at the bottom. Carbon dioxide makes up just 0.04%. The rest is just trace gases. So we are constantly relying on that very specific 21% slice of oxygen to sustain combustion and, well, life on Earth. Section 3. Exposing the invisible byproduct. What happens after the oxygen is consumed? You see, combustion is a two-way street. It doesn't just consume a gas and make it vanish into thin air. Chemistry dictates that it has to leave something else behind. It's a chemical process where a substance reacts rapidly with oxygen gas. But here is the absolutely crucial takeaway. It produces carbon dioxide as a direct byproduct. So as the oxygen levels go down in that sealed jar we looked at earlier, the carbon dioxide levels go up. It is the inescapable, invisible exhaust of the combustion engine. So how do we actually know the carbon dioxide is really there if we can't even see it? Well, here is an old school but highly effective chemistry trick that makes the invisible visible. Imagine a jar containing a burning candle and a small cup of perfectly clear lime water. After the candle burns up all the oxygen and goes out, you take the candle out, seal the jar back up, and shake that lime water around. Look at the result. That once clear liquid turns milky and cloudy white. This happens because carbon dioxide chemically reacts with the lime water to form a white precipitate. That milky color is absolute, undeniable visual proof that carbon dioxide was just generated by that flame. Section 4. Measuring what we breathe. The tools used to track invisible gases. Notice the crazy evolution of our measuring tools here. On the one hand, we have chemical gas detection tubes. These things are fascinating. They're glass tubes filled with a chemical substance. You just snap off the ends, pop it into a pump, and pull the handle. As the air gets drawn through, the chemicals react with specific gases, literally changing color right before your eyes to show you the concentration. But contrast that with the modern, highly sensitive digital gas monitor. It comes complete with a probe sensor and a digital screen that reads out highly accurate data in real time, 0 chemical reactions required each time you use it.
So why does all this matter?
Well, chemical tubes are fantastic for quick, single-use, visually clear checks. But those digital monitors, they are literally life-saving tools. As noted in our source material, these precise digital sensors are used in hospital intensive care units, ICUs, to constantly monitor the exact percentages of oxygen and carbon dioxide for patients suffering from severe breathing issues. By mastering the science of these invisible gases, we've actually developed technology that keeps people alive. How cool is that?
Section 5. History and the greenhouse effect. The macro impact of our combustion dependency.
Think about this depiction of ancient Egyptian craftsmen. Now, they obviously didn't have pie charts or digital monitors, but they totally knew the secret of the flame. They understood that if you use bellows to forcefully pump more air, and therefore more oxygen, into a fire, you drastically increase the temperature of that flame. They used this exact technique to generate enough intense heat to smelt metals, like gold, for jewelry. It was a massive technological leap forward for civilization, and it was all driven by our understanding of oxygen and combustion.
However, if we zoom out and look at the macro impact of this long, long history of burning things, it brings us right to the greenhouse effect. This is defined as the phenomenon of rising global Earth temperatures, which is directly caused by an increased percentage of carbon dioxide in the air from various combustion processes. Remember that tiny 0.04% of carbon dioxide in the atmosphere we saw earlier? By continually burning fuels globally, relying on that exact same basic combustion process those ancient Egyptians used, we increase the output of that invisible byproduct, carbon dioxide. And as it accumulates in the air, it traps heat, which leads to rising global temperatures. Section 6. Harnessing the sun. Renewable solutions for a cleaner future. And this actually brings a wave of incredible optimism. Just look at the sheer scale of the Ben Solar Park, located about 35 kilometers from the city of Aswan in Egypt. Instead of burning coal, oil, or gas, instead of relying on oxygen and emitting carbon dioxide, this sprawling facility uses solar panels to capture the immense energy of the sun and convert it directly into clean electricity. It is a monumental shift. It perfectly illustrates how we can generate the massive amounts of power our world needs while totally eliminating that carbon dioxide byproduct from the equation. A real game changer.
We've gone from a single candle trapped in a glass jar to ancient craftsmen forging gold, all the way to massive fields of high-tech solar panels soaking up the sun. The evolution of how we understand and use energy is truly breathtaking. Which leaves us with this final thought to ponder today. As we transition from ancient flames to solar fields, what will power our next great leap forward? The history of science tells us the answer is out there, perhaps waiting in the invisible elements all around us. Thank you so much for joining me on this explainer, and keep your curiosity burning.